A complex fraction is a rational expression with a numerator and or denominator that's also a rational expression. So, for example, here you can see the numerator in this first example is 4 over 5. So what this basically translates into is 4/5 divided by 5, which we know is really just 5 over 1. We flip the second and multiply. What's happening here is this denominator is actually moving up and getting multiplied by the numerator. So we have 4 times the denominator being a 5. Probably should have chosen a different number for that, over 5. So 4/5 divided by 5 just turns out to be 4. Now, if the rational is in the denominator, 5 divided by 4/5 turns into 5 times 5/4. So whenever you divide by a fraction, you flip it and you multiply. So this becomes 5 times 5 over 4, or 25/4. And same kind of thing, we have a fraction in the denominator, one in the numerator as well, but it doesn't really matter that much because this whole thing is coming down to 3/5 divided by 4/5, which is the same as 3/5 times 5/4, or 3 over 4. Now, we did all of those examples with just normal numbers. The nice thing is you can do that with rational expressions when they're polynomials as well. Those were all just the techniques of complex fractions with rational numbers. The same mechanics work with the rational expressions. So if you notice, for example 6, part A, I have fraction in or rational expression in the numerator and the denominator. So it's going to be like this third example here. A plus b over 4 times 4 over a squared plus b squared. And the 4's cancel out, and we're left with a plus b over a squared plus b squared. Now, because it is a sum of two squares, I can't factor it, and this is my answer. And if you don't believe me, let a equal 2 and b equal 3. And let's see whether or not we could actually factor that down into 1 plus 1 over a plus b. Let's see if those two things are equivalent. 2 plus 3 over 4 plus 9 is 5/13. Definitely not the same as 2 over 5. Those are not the same number at all. So even though it looks like they should be able to cancel out, they can't because I cannot factor that new denominator, a squared plus b squared. So just be wary of that. That's the thing that happens. Lots of times people have stuff like x plus 3 over 3, and they cancel the 3's out and turn it just into x plus 1, but it doesn't work that way. Go ahead and plug any value in for x there that you want. Except for maybe 3, and it's not going to work. Like if you plug a 1 in, 1 plus 4, or 1 plus 3 is 4, it'd become 4/3. 1 plus 1 is 2. Definitely not the same number. So just watch out. All right. Another complex fraction. Again, you'll see we've got rational and rational here. So we're going to just take the rational in the numerator, and it's going to become the product of the reciprocal of the denominator. And here you might notice a couple things. I can factor some stuff here. So I'm just going to write x squared, and here I have y minus x when the other thing is starting with x. What if I factor a negative 1 out from that? It becomes x minus y. That might be handy. X squared minus y squared is just a difference of squares. So it's x plus y, x minus y. If I hadn't factored out that -1, I would have never noticed. And then 4x. X minus y cancels. This x cancels with one of those. And we are left with negative x over 4 times x plus y. Now, sometimes I get asked about where the negative goes. Well, let's look at a couple examples with just numbers. Negative 4 over 5. That is the opposite of 4/5. Well, 4 over 5, -5, is also the opposite of 4/5. So these two expressions, even though the negative sign changes, they're actually equivalent to each other. So it's okay to move something like this -1 that we just did in the last example to have it in the denominator if you want to. One way you can always take care of it is just to put it in front of the fraction bar. Now, the only thing that matters there is moving it to the right location for whatever you happen to do next with it. But these two expressions are technically equal to each other.